don't take it apart, turn it on first. Hi there, I'm playing with junk again, and I just recovered this thing here from the junk bin. I don't know exactly what's wrong with it. It seems to work for me, but I don't have any external attachments. I don't have the electrodes and stuff. Maybe there's something wrong, but it's certainly interesting to have a look at it. It's a ARGUS LCMplus patient monitor from Schiller, a Swiss company, and it can measure CO2 in the breath of the patient. It can measure blood pressure, which is attached here. It can measure the amount of oxygen in the blood, the oxygen saturation. And it can also display the ECG, and if something of these values is out of the limits, it makes an alarm, calls the nurse, whatever you program. Setup is here. There is the ECG setup, graphic scale. You can enter some diagnostics. You can set if the patient has a pacemaker or not, because that influences the ECG. You can say what kind of alarm you want, what cable type you have. At the moment I have no cable. NIPV. Oh, that's blood pressure. NI, I don't know what NI means. Automatic measure off. You can set it to take measurements every, I don't know, hour, half an hour, interval time, yes, to 30 minutes. Deflation speed. Okay. CO2 measurements. I don't know exactly what this is good for. I know they are measuring the CO2 of the exhaled air, and that leaves some that tells you something about the state of the patient system, what kind of patient you have, an adult, a child, or even a fresh born baby. Date and time is not correct now, but oops, we have an alarm. These buttons are down here are to cancel alarms for individual measurement sections, for example for the ECG. Now we have alarm off ECG, SpO2, alarm off this, and if we turn the fourth alarm off, all alarms off. That can be locked here in the setup, so you need a password to switch off the alarms, because it could be fatal if someone accidentally pushes the buttons and there is no alarm when something goes wrong. The unit also has a battery, but it seems it doesn't work. The only thing I get to work is here this CO2 measurement. Now a pump starts sucking in through that port. There is a little micro switch that detects if the so-called water trap is installed. That's a filter that holds back any moisture, because the unit here doesn't like any water in the system. And if that micro switch is pushed, the pump starts pumping. Of course, it doesn't display anything here because it's not measuring anything. maybe that's also something that doesn't work. I don't know how it works. Well, let's have a look inside. Well then, that's the input from the CO2 port with the micro switch here that enables the port when something is plugged in, goes into this metal case here. Then we have a loose hose here. That's the output of the pump. We will see later when I remove the sheet here. Then we have the connection for the blood pressure measurement. Blood pressure measurement is relatively simple. You get one of these sleeves around your arm that can be pumped up with air. And you have a sensor on your finger or maybe inside this sleeve. And it pumps up until the bloodstream through your arm stops, and then it releases a little bit of pressure until the blood starts flowing again. And there you have the point where the air pressure inside the sleeve and your blood pressure is equal. So you only have to measure the pressure of this air here, and you know the pressure of the blood if you can monitor the pulse somewhere on the finger. So that's the pump here that pumps up your sleeve. There is a release valve because you also have to release the air. If you let that sleeve pumped up, your hand will fall off after a couple of hours. Then a second hose goes to this unit here. That's an overpressure switch that gives some alarm if the pump is pumping too much, and then it goes down into this metal box here. I got the board out. You may have noticed there is just a normal transformer. That's the mains transformer. And many of these medical devices do have a traditional linear transformer because it's safer. They may have a switched power supply after the transformer, but for mains insulation they rely on big transformers. They're specially insulated, primary versus secondary, because on such a unit you're connecting a living human, and the last thing you want is that he gets shocked because your power supply is faulty or something like that. I think people that are attached to a machine like that have enough problems, so they don't need an electrical problem too. So here is the screen, just a standard LCD with a connector. Backlight connector must be disconnected before removing the board. That's the ECG port here with the connector that goes to the board and the micro switch. And after removing all that, we can have a closer look to what's inside the metal box here. So we can see what's inside. This whole module here is an option. That's the CO2 measurement module. It has its own little pump. It has a storage container for the pumped gas, a reservoir, and it is only held with 4 screws. And there is, of course, a CO2 sensor. It only has 2 wires. One is power, the other is communication. It has its own microprocessor here. That's the storage container, a small one. I think that's just to equalize the flow from the pump here. That's the input hose. It goes in, out of the pump to the reservoir. Then it goes to that part here and is distributed to 2 sensors here, and one goes to that one. Yes, first in here. Maybe it's sucking that in from here. That would make more sense. So that's more like, well, however. I have prepared another one of these to have a look inside. I hope you can see everything on the video. That's the block. I have milled it open here. That's the pump. It sucks or blows either way. There is a very, very small hole here. And then there are 3 input or output ports that go to the sensors here. So what they do is, with this tiny little passage here, they are creating a resistor. So how do you measure current, electric current? You use a resistor and you measure the voltage drop across that resistor. It's a shunt resistor. So here it's also some sort of resistor, but for air. It's just a narrow path here. And these 2 ports here go to one sensor. That's a differential pressure sensor here. So if air or whatever gas it is passes through that tiny little hole, there will be a pressure difference between the left and the right side. And if you know exactly how big that hole is, you can say from the pressure difference how much air or gas is passing through that. So they're converting an airflow into a pressure difference by inserting a mechanical resistor. So that's exactly the principle how an ampere meter works. Then we have another pressure sensor here. It seems because it only has 1 port, that's an absolute pressure sensor. It is just connected with the other 2 ports here. So that pressure sensor and that pressure sensor, they should measure the same pressure. And then 1 port goes into that thing here. Sorry, I'm off the picture. It's from a company called Prion, which doesn't exist anymore. They are now a subsidiary of Welch Allyn Corporation. They make all sorts of sensors and stuff. And that's an interesting package because it has its own socket. It looks like a dip chip. And I think we should have a look inside that thing, because it's probably quite interesting how it works. Okay, some operational amplifiers, not much interesting in electronics, but the interesting part is certainly in this package here. It seems there are some stickers here left and right. Okay, that was easy. Everything is glued together, of course. Well, there is a round object with 4 or 5 wires. There is another thing with 2 wires. And the gas input or output, well, more like an input, because that's a sensor. Somewhere in between. Well, it seems I can't take it apart any further. It's glued in place. Everything is more or less one piece, but fortunately I found the service manual of that device here, of the Schiller, what's the name? ARGUS LCMplus. You can Google that, look for maintenance manual. You can find it, it's not so hidden, and it's a really good manual. It explains anything about the whole thing here, every part, any measurement. It's explained how blood pressure measurement works, how the ECG works, and also how this sensor here works. It has a lot of details. So if you're interested in all these things here, including the sensors and how this is actually working, I recommend you to download that manual and have a look at it, even if you don't have the device. But there's a lot of theoretical information that's quite great. So what's inside here? We have a closed compartment, and on one side we have some sort of heat source. Don't know if it's just an incandescent lamp or something. And on the other side we have 2 tiny thermo elements, and they are connected in a way like anti-parallel, so they are connected with the minus to the minus. So what are they doing? They generate electricity, only a little bit, when they are heated up or when they feel a differential in heat. And one of them is blocked by something that blocks out any infrared radiation that comes from here. So one is blocked, and the other one gets infrared radiation. Now here on the side is the CO2 input, and CO2 has the property to absorb some wavelengths of infrared light. Infrared. I'm not sure about the wavelength, but that can be easily found out if you Google in Wikipedia carbon dioxide absorption wavelength. Now the reason why they have two of these thermocouples or thermal elements is there is heat from outside, and that affects both of them. So, and because they are anti-parallel or anti-serial here, if they both heat up in the same way, the output will be 0, because the one makes a positive voltage, the other one makes the same amplitude of a negative voltage, and combined it's a 0. But when infrared radiation from this source here comes and hits only one of them, this one will generate a positive output here and of course a negative output here. So they take 2 for temperature compensation, for the outside temperature, and one of them is used to measure how much of this infrared radiation comes through. And if everything is properly calibrated, you blow in the CO2 gas, and this will absorb a certain amount of this. So there's the gas here inside, and this will absorb some of this infrared radiation, and then you know how much CO2 is inside the chamber here. That's what's happening here. I assume, because this is a better insulation, especially for heat resistance, this is probably the infrared or heat source. And here, because of the many wires that come out, we have 1, 2, 3, 4, 5. Don't know why they need 5. They will have their reasons. That's certainly this thermocouple thing, all in one case. Should be interesting to get that out. I'd like to see how it looks from the front. Then they go down to some operational amplifiers, and we have an input and an output, and the other pins are just straight through to the sensors. I think they are not needed from the outside, but they left it to have a better seat on in the socket. That's the infrared light source. It looks a little bit like a little light bulb inside with a reflector and a flat glass over it. Maybe it's also some kind of LED, but I think from the, if I look at the wires, it looks more like a light bulb, or maybe it's even some sort of resistor that gets very hot and emits a long wavelength infrared. I don't know. Maybe someone can find a data sheet. I had no luck about that with that. So, and that's the sensor part. It came out not by itself, but with a little bit of goodwill from my side. Has 5 wires. Has a marking. It says something 80403. Maybe you have an idea what that could mean. Maybe if I could get rid of this white glue here. It's not so easy. Everything is hard like concrete. Now that's useless. Okay, nice little infrared sensor used to measure the amount of CO2, carbon dioxide, in this unit here. Okay, what else do we have? That's the same unit from this device here. That's the ECG input from the green connector. It has some, what's that? Capacitors, SZNR. That's probably some sort of voltage protection, over voltage protection diodes. All the inputs on this unit are protected against 5 kilovolts of foreign voltage, because these medical monitors here are made to stay on the patient. For example, when they get a shock, an electric shock from the defibrillator. These defibrillators work with voltages up to 1000, maybe even more volts. And of course, in an emergency, you don't have the time to remove all the electrodes and everything before you can give the patient a shock. Everything has to go fast, so all these inputs are protected against that. Minimum protection is 5 kilovolts for all the inputs. We have here 12 channels in total. Most of the time you only use 3, maybe 5. The rest of it is like an oscilloscope, a very slow one. There are input amplifiers, input filtering, everything of course with optocouplers, also to protect, not only to protect the unit from these electric shocks, but also to protect the patient from if anything goes wrong inside here. Everything is totally electrically insulated. Even this little transformer here with a wire to the other side. Insulation gap all around. Total insulation of also on the back side here. That's the plug that goes to the unit that still is here in the back. That's the SpO2 measurement unit, and also where the temperature sensor goes. This is also an option. You can have different options of measurement methods here. So the SpO2, that's the saturation of oxygen in the blood. So normally if you are a healthy person, you have something between 90 and 100%. If you're not working extremely hard or holding your breath for a minute or two, you shouldn't do that. How do they measure the oxygen in the blood? It's also very simple. It's in the end an optical measurement, also like the CO2. Let's draw another sketch. Where is my writing tool? So let's assume that's your finger with your fingernail. Let's zoom that in a bit. Then inside your finger there's a lot of blood, of course, that circulates around. And what you do is, for example, you take a clip like that one. That's a portable, battery operated and a little bit dusty SpO2 meter, and it works like that. If the batteries are still working, no, they're not. Okay, it beeps. Okay, low battery. Let's try again with new batteries. reduce the light. Then you can see what's beeping is my pulse. You can see that here. That's the strength of my pulse. There's also a little graph of my blood pressure. Well, it doesn't measure the blood pressure, but the intensity of the pulse. And my saturation of oxygen is at the moment 96%. That's okay. If I breathe, maybe I can get it up to 97. I definitively have my pulse rises a little bit. Okay, and what it does, it's quite simple. You also have some light source, infrared and red. You have two lights shining through your finger, because if you take a bright light, your finger is transparent. You can test it with a torch. Shine through your finger, you see red light coming through. And then you have two photosensors that are attached to some electronics. And what it does, you have two different wavelengths here. Let's name them 1 and 2. And depending on the amount of blood, the amount of oxygen in your blood, one of the two wavelengths will be absorbed more. So if at a certain level, let's say 100%, both are shining through in the same way, and if you're going lower, there is an imbalance. One is going greater, the other is going smaller, maybe that way, maybe that way. And from this imbalance in voltage 1 and voltage 2, you can determine the amount of oxygen in the blood. Of course, everything has to be calibrated, and but that's about how it works. The problem is when women try to use this and they have nail lacquer on their nails, especially if it's blue or green, this will probably affect the result of this measurement. So you can also use a toe, or there are also clips for your ear lobes. But if someone gets delivered into hospital and all the fingernails are painted blue and maybe they have a lot of piercings, they have to remove that nail polish here just to get the correct measurement, because the blue or green will filter out too much of this source here. And if you look at the sensor, it's exactly down here. Oops. It's this little thing here, and that's the one on the other side. I'm not sure. Yeah, now you can see it. And that's exactly the location where your fingernail is, because there is no bone inside the finger, and it's the best way to shine that infrared light through. Okay, that's how that works. This is also explained in this service manual, and also that kind of sensor. Everything I know here is from that service manual. That's pretty cool. Well, let's have a look at the board. Let's zoom out. There's a speaker. Yes, transformer, power supply, microprocessor, Motorola something. That's Epson, that's the video processor, graphics card if you want. That's the connector for the LCD that goes directly through this driver here to that video chip. We have some, that's a flash ROM, that's where the firmware is. These things here, don't know, maybe RAM, maybe ROM. Input stuff, some more measurement. That's the pump for the blood pressure measurement, overpressure switch. Well, input channels from the ECG, little relay, and also a pressure sensor here. That's the one for the blood pressure. Inverter for the backlight. It still has a fluorescent backlight in the LCD panel. All the buttons here, all kind of from the front panel. And that's the other module for temperature measurement. We could have a look inside that. I think it's not too exciting. That's the input for the temperature probe. It's a standard 6.3mm jack. You can also plug your guitar in here. Won't work, but at least the plug will fit. That looks a little bit like an AD converter. Maybe yes, maybe no. A lot of opto couplers here. Also, everything is electrically insulated. So that's the transformer that gets the power in, also electrically insulated. I think that's a little bit power supply part. Oh, here also this temperature sensor is somewhere on the patient, maybe somewhere in the patient. And what you certainly don't want is any voltage, any current flowing through that thing, killing your patient or hurting him. So there is quite a big chip here. That's the SpO2 measurement module. Ooh, that is a little bit a weird angle for that transformer. Seems that was done during manufacturing. It's soldered in this weird position. That's not very Swiss made. So that's from the Massimo Corporation. So it seems this module has not been designed by Schiller. Massimo is a company that makes especially SpO2 measurement things. Now that's funny. This plug here is not in the right position, and that's one I haven't unplugged yet. But I also had the feeling, well, there is no correct position. Okay, must be like that. They make a 11-pin header for a 10-pin connector. Why not? Okay, I think that's it. Thanks for watching.